So hello friends, this is Parag Desale. I welcome you all in this lecture series on fluid mechanics. In the previous session we have seen some of the numericals on flow through pipes. Now we'll continue that. So let us read the problem. Given data I will try to write down. I expect that you should also read the problem first and try to write down given data at your own. You have to analyze the situation. The pipeline of a 600 mm diameter. So diameter of the pipeline is how much? 600 mm. That is nothing but 0.6 meter. Is 1.5 kilometer long. Length of the pipe is what? 1.5 kilometer long. That is 1500 meter. Now this is the pipe given. To increase the discharge, another pipeline of same diameter is introduced. Okay, now they are changing the arrangement. To increase the discharge, the another pipeline of same diameter is introduced parallel to the first in the second half of the length. Now what we'll do, now whatever this arrangement is, this is modified. Now we'll firstly try to figure out what is the original arrangement to read the problem completely. If F is equal to, F is given as 0.04 and head at the inlet is 300 mm. Calculate the increase in discharge, neglect the minor losses. They are saying that there is a, I can arrange this diagram as, this is a tank where there is a 300 mm head is available and it is connected to a pipe which is straight and of length equal to 1500 meter. This is the length of pipe and the head available at the inlet is how much? It is only 300 mm. Now from this is the original arrangement and they want to modify this arrangement where the parallel section will be added and discharge will increase. So to understand and asking us to find out the max increase in discharge. To calculate this increase in discharge you must know original discharge. So firstly we will try to find out this original discharge. So that will be something here as, let us say, Q dot is flowing through this and how much is the loss now. As you can see that this is the head level at this side and exit is open to atmosphere, so the loss will be the difference between the inlet and outlet. If outlet would have some reservoir, the level of that, let us say H1 minus H2 will be the H loss, but here H2 is 0, so H loss is completely 300 mm. So you can figure out from here that total H loss is how much? 0.3 meter, that is 300 mm. So now we need to find out the total discharge and there is single pipe, so simply you can find out it with the H loss equation, that is HF as FL discharge square upon 12.1 into D raised to 5. So this is your original equation for Darcy-Wiesbach equation in terms of discharge. So if you observe this, you will put all the values and you can get the discharge, original discharge value. So I can call this at original without any modification. All the values are known. If you observe carefully, put them all and you will get the value of discharge in meter cube per second. You can observe F is known, that is 0.04, length is 1500, 12.1 into D is 0.6. So everything is known, only discharge is unknown, that you can obtain. Once the original discharge is known, now we'll go for the modification. Now what they have modified in this problem, to increase the discharge, the another pipe of the same diameter, they are introducing another pipe of the same diameter is introduced parallel to the first. Means what? The another pipeline will be parallel to this first, but in second half of the pipe length. In the second half of the length means what? The arrangement, if you could figure out, I will draw the diagram. This is your tank, original tank as it is I am drawing, and this is your original pipe. Its length is 1500 and now half of this means what? 750. At 750 they are introducing the second pipeline. So I can, and the second pipeline is parallel to the second half of the pipe, parallel to the second half of the pipe. So here it is the, because of these two branches now discharge is increased. So whatever the inlet will be equal to outlet. So if I call the discharge at inlet as q dot 1 and this as, let us say, length 1 will be this pipe as length 1, this pipe as length 2, and third pipe which is in parallel, that as length 3. L1 equal to L2 equal to L3, because they are saying that it is in the second half. Means what? This is the half of the pipe. So this one will be 750, this one will be 750, and this is parallel, so they are also in 750. So all L1 equal to L3, L2 equal to H3, all are how much? 750 meter. And the diameter is also same. They have said that the diameter is not changed. In the problem it is mentioned that diameter is same, so it is 0.6 meter. Another pipeline of the same diameter means what? 0.6 meter. This D3 is also 0.6 meter. And F, as we know that F is constant, so I can simply write down F1 equal to F2 equal to F3 as 0.04. F is not changing, same pipe is used. And they are asking us to find out the increased in discharge. So what will be the increased? Now this is q dot 1 is entering. I'll call this as q dot 2 leaving from the second pipe and q dot 3 leaving from the third pipe. So continuity equation says that total inlet equal to total outlet. So total inlet is how much? So total inlet is q dot 1 and total outlet is how much? Q dot 2 plus q dot 3. Q dot 2 plus q dot 3. So that is continuity equation. Total inlet equal to total outlet, and this is the total discharge. Q dot 2 plus Q dot 3 is the total discharge, and that is nothing but the Q dot 1, and that will be more than this original. Okay, so difference between them is the asked. What is the difference between them? This is the question. So if you observe this carefully, there can be two arrangements. These two pipes are in parallel and these two pipes are in series. So for parallel arrangement, head loss remains constant, HF2 equal to HF3. So for parallel arrangement, 2 and 3, pipe 2 and 3 are in parallel to each other, so HF2 will be same as HF3. This will give you some relation between Q dot 2 and Q dot 3. You can write down, see here now, that is F2 L2 discharge 2 square upon 12.1 D2 raised to 5 equal to F3 L3 discharge 3 square upon 12.1 D3 raised to 5. You can observe carefully, F is same, 12.1 can be cancelled, L is same, D is same. So it indicates clearly that Q dot 2 is same as Q dot 3. Q dot 2 is same as Q dot 3. So if you modify here, so it will become Q dot 1 equal to Q dot 3 is same as Q dot 2. Q dot 3 is same as Q dot 2. So I can put this as Q dot 2. Q dot 2 plus Q dot 2, it is twice Q dot 2. I can again modify this as Q dot 2 can be 1 upon 2, or it can be written as 0.5 times Q dot 1. So I will use this equation now in arrangement of series. So if I write down this for pipes in series, so pipes in, which are the pipes in series? That is 1 and 2. Pipe number 1 and pipe number 2 are in series to each other. So if I write down the equation for them is what? Total loss will be, total loss is how much? 300 mm. 0.3 meter is the total loss, and that is how much? HF1 plus HF2. So total loss is HF1 plus HF2, and I can write down that is as 0.3 meter, which is HF1 is what now? It is F1 L1 discharge 1 square upon 12.1 D1 raised to 5 plus F2 L2 discharge 2 square upon 12.1 D2 raised to 5. You can observe that FL 12.1 and D are common, and that can be taken as common, and the values are F1 is what? 0.04, L is how much? So half of this is L1, that is 750 mm, 750 meter, and this L2 is also 750 meter, so it can be taken common. L1 and L2 both are same, so taken common, 750 divided by 12.1 can be taken as common, and diameter is also same, and that is 0.6 meter. So 0.6 raised to 5. In bracket what will remain? Only q dot 1 will remain to the this side, and the second part is q dot 2. And what is q dot 2? Q dot 2 is what? 0.5 times q dot 1. So 0.5 times q dot 1 bracket square. So if you observe this equation, it is only quadratic equation in terms of q dot 1. So that will be the answer. Q dot 1 is the new. Here you have to take, this is quadratic equation, so it will give you two roots of the discharge, and solving that you will get positive root and negative root, that you have to take positive root of the equation. Okay, so positive root of the equation will be new discharge, and so rise in the discharge is q dot 1 minus q dot original. That is your answer. Okay, so I hope that is clear to you. So now we'll go for the second question. So let us start the second problem. Here I can write down the given data. A piping system consists of 3 pipes arranged in series. Lengths of the pipes are, now there are 3 pipes arranged in series. L1 is how much? 1200 meter. L2 is given as 750 meter, and L3 is 600 meter. And diameters are 750 mm. Now D1 is 750 mm. Convert that into meter as 0.75 meter. Then D2 is how much? 600 mm. This is mm, so it is 0.6 meter, and D3 as 450 mm, that is 0.4 meter. Transform the system into an equivalent 450 mm diameter pipe. Now equivalent pipe is asked. Whose diameter is asked as D equivalent as 450 mm. That is means what? 0.45 meter. And determine an equivalent diameter of the pipe. Transform the system to an equivalent 450 mm diameter pipe. Now transform means what? Find out its length. L equivalent is asked. And so second part of the question is determine an equivalent diameter. Determine an equivalent diameter for the pipe if the length is 2550 meter long. And second, this is the first part. First equivalent pipe is asked, and second equivalent pipe is asked as L equivalent is given, that is 2550 meter, and diameter is asked. So there are two sub questions. One is diameter is given and length is asked. Second is length is given and diameter is asked. It is very easy problem. You can simply solve with the Dupuit equation. I will just list down that. What is that Dupuit equation is? LE equivalent upon D equivalent raised to 5 equal to L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5. So in this problem you just have to compute this constant. If you put the all values here, you will get some value of constant. Okay, now once you got that constant, diameter is given, find out the length, and length is given, find out the diameter. So it is very simple problem. I think I need not to discuss anything anymore about this. You just have to put these all values. Okay, once you put the all values, you will get some value here, constant value. Now you have this value. If you have the diameter, you will get the length. If you have the length, you will get the diameter. So both can be solved. So in the first case, what you will do? In the first case, you will do 0.45 raised to 5. This will be some value. Multiply by this value, you will give you the length. And in the second problem, what you will do? Put the L equivalent as 2550. So here 2550 will be inserted. You know this value, you know this value, you will get the equivalent. So this is second is solved. So I hope it is clear. This is very simple problem based on Dupuit equation. So let us start the third problem. I'll read it. So what is given? A 2500 meter long pipe. Length of the pipe is how much? 2500 meter. Long pipe is used to transmit the power. Now power transmitted is given. Power transmitted is 120 kilowatt. Immediately convert this into SI units, that is watt. So 120,000 watt. Pressure inside the pipe is 4000 kilonewton per meter square at inlet. So I can write down this as P1, that is inlet pressure is how much? 4000 kilonewton, na? Means kilo means 10 raised to 3 into 10 raised to 3 Newton per meter square. So I have taken this kilo as 10 raised to 3 Newton per meter square. At inlet means P1. If the pressure drop over the length of the pipe is 800, means P loss is given. This P signifies for pressure, not for power. P loss is how much? 800 kilonewton. That is also 10 raised to 3. I should have written this as 800 into 10 raised to 3 Newton per meter square. And the remaining quantities are given as F equal to 0.024. If water is flowing, means what? Density of water is 1000 kg per meter cube. Is flowing through the pipe. Find out the diameter. First is diameter is asked. Second is efficiency of power transmission is asked, and third is maximum efficiency is asked. Now that is clear that maximum efficiency is 66.67. Just two quantities has to be obtained. Now to obtain the diameter, you must be clear with the discharge first, because you have the H loss but you don't have discharge. So for that discharge you will use this power transmitted. So if you know the power transmitted, how much it is, it can be written as power equal to mgh. Mg is what? M dot into rho q is the m dot. Rho into q dot is the m dot. Mg into h. Now what is h? hb it should be. Let us say this is the section 1 of the pipe, section A of the pipe, and section B of the pipe. Because when I took the derivation for this, I have taken this as B and this as A. So HB is the head available at B and HA is the head available at A, and the difference between them is the H loss. So H loss is what? HA minus HB. So this is the head available at section B, means what? This much power it has. So we supplied HA but we got HB. So corresponding to HB, how much is the energy? mgh, and that is power available at the section B, and that is nothing but the power transmitted. So how much it is? This is known to us. Q is rho is known to us, G is known to us, HB is can be obtained by difference of this, and we get the discharge. So to get the HB first, we should use HA minus this. I'll signify this as HA instead of PA. Firstly, we have to convert these both quantities in terms of meter, because they are given in terms of Pascal. So what is pressure? PA is equal to rho G HA. So what will be HA? HA will be PA upon rho G. So you will obtain that PA is how much? 4000 into 10 raised to 3 upon 1000 into 9.81. So you will get some value of HA. So I will compute it for you fast. 4000 divided by 9.81, 10 raised to 3 will be cancelled. So it is 407 meter, 0.75 meter. And similarly you will find out H loss as P loss upon rho G. So how much is the P loss? 800 into 10 raised to 3 divided by 1000 into 9.81. So you will get P loss as 800 divided by 9.81. So it is 81.54 9 meter, and the difference of them is nothing but H loss. So here I have written this. So HB will be what? HB will be HA minus H loss. So it is HA minus H loss. So the difference of them is the HB. From here we got this. So HA is how much? 407.75 minus 81.54, that is 326.2 meter. So this is what the head available at the section B, and that is nothing but the power available. So if we put this value of HB here, we know 9.81 as G, 1000 is density, and power is 12000. You will get the value of discharge. So from here you will get the value of discharge, that will be in meter cube per second. So if in fast I can compute that 123 divided by 1000 into 9.81, 1000 into 9.81 into HB, 326.2. so that is nothing but 0.3749. Okay, so this is what your discharge is. Now once you got the discharge, you can compute everything else, whatever the required is. What is first requirement? Diameter. So for diameter you have the equation for H loss. H loss is what? FL discharge square upon 12.1 into d raised to 5. So everything is known here. If you put the value of F as F is given, yes or no, 0.024, length is given as 2500, discharge is to be obtained, sorry, discharge is given, that is we have calculated it. So 0.03749 square divided by 12.1 into diameter is to 5. The diameter is to be obtained. H loss is known to us, so we have H 81.54 is the H loss. So only discharge is diameter is known. You can compute that diameter. That will be your answer number 1. And what is the efficiency? Second one is efficiency of transmission is what? HB, available power available at the outlet, divided by power available at the inlet into 100. So power available at outlet is how much? 326.2 divided by power available at inlet is how much? Supplied power is, in terms of meter, if I calculate, that is 407 point, both quantities must be in meter, into 100. So that is what answer, 326.2 divided by 407.75 into 100, that is 80%. And we know that maximum efficiency is how much? It is you are at some HA equal to 3 times HF. So this is what your maximum, with the value of this, if you put here, you will get the maximum efficiency as 66.67%. So okay, we'll stop here now, and in the next session we'll see the numericals on siphon. So thank you very much. If you like these videos, do subscribe the channel to get the notifications about incoming lectures. Thank you very much.